Hello guys, so I can see few people are there online already, so we'll wait a few more to join. So in case you have any topic for discussion, you can tell me that. We'll start from there because last time we did a full revision on all the topics. So if you have any particular question today to be discussed, please let me know. You can always take a picture and post it in the group, WhatsApp group, and I'll take it from there and I'll explain. So otherwise, if you have any other topic also to be revisited, please tell me that. So here we have students from all the three NPSs. So depending upon the time availability, we'll be trying to cover as many topics as we can. So feel free to post your queries. Any particular topic you want me to start off with? Any one of you, please post it in the comment section. You can do that. Yeah, any topic, guys, please tell me so that I can start explaining that. So where do I start from? Which topic do you want me to cover first? Or I'll do a general revision if you don't have any particular topic. in physics, so there are two sets of people who are there with us right now. So one is our NPS Kormangla and HSR. So they have same syllabus. NPS RNR has a little bit different syllabus, but there is lots of concurrence. Okay, so let's first see what all were the common topics. So one is your first chapter is motion. Then second chapter was laws of motion, Newton's laws. Newton's laws of motion. And third one is, oh, I have not shared my screen yet. Just a moment. I'll share the screen first. Wait a minute. So, yeah, so I will be sharing my screen now. Yeah, so I hope all of you are able to see my screen now in a few moments. Yes, so I was explaining that we have two sets of students here. First set is going through the topics they have to cover is motion, Newton's laws of motion, and I think there is gravitation and pressure, small bit of pressure. And NPS RNR, apart from all these, they had units and measurement. Then over and above this, they have turning forces. I think these are the total. There's a total syllabus to be covered. There's a total syllabus of physics in all the schools. Yeah? So RNR has these two topics extra. If I am missing anything, you can just post it. Okay, so what I'm going to do is I'm going to solve one worksheet so that all the entire syllabus is covered. Okay, give me a moment. So what I'll do is I'll give you a worksheet to solve. Okay. So let's start with motion, chapter motion. Okay. Yes. So these are the questions. So what I'm going to do is I'm going to questions. Okay, now I am sharing the screen once again, full screen, so that you can. Yeah, so now there is a worksheet on your screen, and let's start solving one by one. Okay, so all of you have to answer here. You can answer here itself. So which of the following statements is correct? Both speed and velocity are same. Speed is a scalar and vector. Velocity is a vector. Speed is a vector and velocity is a scalar, and none of these. What is the answer? So you can type in your answer in the. Yeah, you can type in. All of you can type in your answer here in the. Great. So you could solve the first one. Your answer is B. Go for the second one. What is the slope of the body when it moves with uniform velocity? Question number, so you'll have to write question number 1B like that. So question number 2, what is the answer? Answer, question number 2 is, so you'll have to write 2A, 2B, 2C, 2D, whatever. So like that, so that I can, clearly see who is answering what. Two B, what? So slope. What is slope of any slope of? So question was what is the slope of the body when it moves with uniform velocity? So actually, when we talk about slope, it is velocity time graph. So in actually they should mention which graph you're talking about, but let me explain this. So let's say if it is velocity time graph, then the slope the slope represents acceleration, right? So slope of a velocity time graph represents acceleration. But if it is, so what is slope basically? So slope, so this is the slope delta v, and this one is delta t. So slope, or a was given as delta v upon delta t. That was slope. But if it is a distance time graph, then the slope will give you loss. If it is a displacement time graph, then you'll get. So let's say this is a displacement and this is time. Then the slope will give you. See, this is delta s. This is delta t. So here velocity, or if it is displacement time graph, it will give you velocity. If it is distance time graph, it will give you speed. So delta s upon delta t. Okay, next, let's go to the next problem. So which of the following is the position time graph for a body at rest? Try this, guys. Body is at rest. Yes. So first one is the right answer. Why? Because if you let's analyze this, and we'll talk about all the four cases. So let's say, so this was question number. So this is the question. Now, basically, how do we find out? So if this is, so position is not changing with time. So this is basically at rest. This is at rest. So this is rest. What about these? What type of motion is it? Can you tell me? 3-2. What is 3-2? What is this 2? What type of motion is it? Please tell me what type of motion does the graph 2 represent? So is it, clearly body is not at rest, but is it moving uniformly or non-uniform motion? What is it? Sorry. Uniform motion. Why is it uniform motion? Because the slope is constant. Throughout the journey, the slope is constant. So delta S by, so slope here in this graph, slope is equal to delta S upon delta T. Delta T is constant. So hence it is uniform motion. Okay. What about this one? Third one. What is this one? Third one. What type of motion is it? Uniform, non-uniform? Third one. Third is uniform. So why? What is the difference between second and third then? Uniform towards zero. What does it mean? What is the difference? Uniform deceleration. Uniform deceleration. Yes, guys. So why are these in the third one? It's moving in the opposite direction. But which direction is it? Deceleration. It's not deceleration. Karthik, it's not deceleration. Clearly, it's not deceleration. But was it? What is it? Deceleration. It's not deceleration. Towards origin is the right answer. Correct. So in the third case, the body is moving uniformly, but it is moving towards the opposite to the positive direction. Correct. So it is what is the case? Case is something like this. Let's say there is a uniform, or let's say the body is moving in this direction, and this was the origin. This is origin 0. So in this case, the body is trying to move, or basically it is moving in this direction. Right. So let's say it is moving in this direction uniformly. So when this happens, then we say that it is uniform motion, but towards the origin. Towards origin. What about the fourth one? Try this. What about the fourth one? Fourth one is positive acceleration. So it is accelerating. Yeah. So it is. Yeah. In this case is accelerating. Isn't it? If it was deceleration, then what would it be like? Deceleration in a velocity, in a position time graph. Yeah. So deceleration would look like something like this. Deceleration. Okay. Now, let's go to the next question. What does the area velocity time graph give? Area in velocity time graph give? Question number 4. Solve question number 4. What does area of velocity time graph give? 4 is C. Displacement. Correct. Now differentiate between distance and displacement. 4C, all of you know that it's very easy. What is difference between distance and displacement? So you can one by one, tell me the difference between distance and displacement. So let's say we have to differentiate between distance and. So let's say we have to differentiate Let's say we have distance and displacement. Tell me the differences one by one. Distance and displacement. Let's enumerate all of them. Yeah, great. So first, no, before you go to scalar and vector differentiation, what you can say, first define it. What is distance? It's nothing but actual length of the path traversed or traveled by, we say traversed by a body, right? Actual length of the path traversed by a body between point A and B, right? So this is difference number one. Here you will write the shortest distance between the origin and destination, right? So you give example also. So let's say you will give example like that. You draw a picture. Let's say this is A, this is B. So distance equals length of path A to B. And displacement, you can use a different color maybe, and then use, yeah. So you can highlight a label here itself. So this is displacement. Okay, and this one is distance. To draw diagrams also. Okay, first this thing. Second difference is clearly many of you have also already highlighted. It is a scalar quantity. And here it is a vector quantity. Okay, then third is it can only be positive. There cannot be any negative distance. Positive. And here it is, it can have negative values. It can be negative also. It can be negative. Okay. Correct. So in this thing, distance is always greater than equal to 0, and displacement can be either less than 0, greater than 0, or even equal to 0. Okay. Yeah. So most of you know the difference. So next question would be, derive mathematically the first equation of motion. So let me take it here. Yeah. Okay. So what is meant by, or let's say if this question comes, derive mathematically the first equation of motion, that is v equals to u plus at. So how will you do it? So basically you have to start with the definition of acceleration. So acceleration is equal to rate of change of velocity with respect to time. Okay, so hence A is equal to v minus u by t. So this is, let's say, or in the intermediate step you can write. In the intermediate step you can always write. So shift it here. What you can do is you can write it as delta v. So hence what will happen? So it is nothing but v p minus u is equal to at. So hence v equals u plus a. And you have to mention where u is equal to initial velocity, v is final velocity, a is acceleration, and t is equal to time taken. Okay, so this is this question. Now, next is, yeah, so question is, calculate the acceleration of a body which starts from rest and travels 87.5 meters in 5 seconds, I believe. Yeah. So hence, let me just copy this question. And so let's say this is a 2-marker question. Let me go there, and we will put it here. Yes. So yeah. So this is the question. So calculate the acceleration of a body which starts from rest and travels 87.5 meters in 5 seconds. In such questions, how do you solve? Solution. In such question, ideally you should draw a diagram just for your understanding. So let's say this is a straight line path. Okay, and let's say this is my point A, and this is point B. And let's say here, which starts from rest. So you can mention all the information here itself. So u equals to 0, and A is unknown. That is what you have to find out. S is given as 87.5 meters, and T is given as 5 seconds. So hence the 3 equation, out of the 3 equation, what is to be found out? A, right? So if T is mentioned, S is mentioned, and U is mentioned, then you know that S is equal to ut plus half a t square. And the question is, why don't we use the other 3 equations? The best way I have discussed in the class, also write all of them. So let's say v equals to u plus at. Then second one is s is equal to ut plus half at square. You don't write this in the solution part. You just write it in some rough space. So v square is equal to u square plus twice of as. So these are the 3 equations of motion. Now clearly, a is being demanded, and there is no talk of v. So ideally, we should restrain from using this equation and this equation, because you don't know v. In this equation, we know s also, we know u also, we know t. So hence, easily we can find out a. So let's deploy the values. So s is 87.5. And before deploying the values, please check that all the units, all the quantities are in the same setup, the same SI units. U is 0, so I don't really care here. So let's say it is 5 seconds. So this is gone. So this is in meters. And then plus half of A and T square. So that is 5 square. Isn't it? So let's not write the units, because everything is in SI units. Now what is this now? So this implies this is 87.5 equals, this becomes 0, and this is 25 upon 2 into A. Yeah. So this implies A equals 87.5 into 2 divided by 25, and the units will be meter per second square. Why? Because everything was in SI units. Okay, so this is nothing but so this is what, 175. 175 upon 25, which is 7 meter per second square. So most of you have got it right. Ishani, calculation 17.5. You are saying it's 7.5. Sorry, 7 meters per second square. Check your calculation, please. Next question. Define uniform velocity and uniform acceleration. Yeah, so the question is define uniform velocity. Yeah, so define uniform velocity and uniform acceleration. So how do we define? So uniform velocity is the velocity or you can define like that. You can say is if a body moves in a straight line in one direction, such that it covers equal displacement. Mind the words displacement. Equal displacement in equal interval of times. Then it is said to be undergoing uniform velocity. Or it is said to be undergoing uniform velocity or said to be traveling with uniform velocity. Yes. And what about uniform acceleration? Uniform acceleration. So you can say that if the rate of change of velocity of an object, rate of change of velocity of an object is constant with respect to time, then the object is said to be undergoing uniform acceleration. Okay, so if object speed is increasing at a constant rate, then it is uniform acceleration. Correct. That's also correct. So this is the difference. Okay. Now next question is derive the second equation of motion graphically. Very good. So let's find out. So we have learned this also. So we have to find what is the question. Question is derive graphically the second equation of motion. Second equation of motion. And what is second equation of motion? Again, whenever there is a talk of equations of motion, I usually reiterate everything. So first equation is v equals to u plus at. Second is s is equal to ut plus half at square. And third one is v square equals to u square plus twice of x. So we know how do we derive this graphically. So displacement is nothing but area under the curve in a vt graph. So this is how we had done it last time. So let's say this is the curve, this is my V, and this is my T graph. And then we have to do what? Let's say this value was U, and let's say this value was V, and this value is time is 0, and this corresponding value of time here is T. Okay, and we have to find out the equation. What do? We have to find out the area of this curve, area under this curve. We have to find out this area to find out the displacement. And how do we do that? So either you can divide this particular geometry into two parts. That is, you can divide this into this, or you can, so basically let's name them. So let's say this point is O, this point is A, let's say this point is B, this point is C, and this point is D. So either you can do that displacement S is nothing but area under VT graph. So what is meant by under VT graph is like, so this will be one boundary. So this is the graph itself will be one boundary. The y-axis will become another boundary. The x-axis will become another boundary, and this vertical line AB is another boundary. So basically, whatever is the area under this area of this trapezium. So hence the area is nothing but area of trapezium. Which trapezium? OABC. Yeah. Or you can also say, either you know the formula, then you can use this, or you can divide it into two areas. You can say area of triangle CDB plus area of rectangle OABC. Either of them you can use. So I know the formula of area of trapezium, and that is nothing but half into sum of parallel sides into distance between the parallel sides. Either you use this, or you do what I can do. Area of this, the second approach. So area of triangle CDB. So what is area of triangle CDB? Is nothing but half to base into height. So it is nothing but half. And if you see, let me just take this picture down so that it is in front of our workout. So let's say I am, yeah. So let me copy this and paste it here. Okay, so what is the area of CBD? So I'm doing the second method. So I am doing area of CBD. So half into CDB is half into T. So half into T. Or let me write in terms of the sides. So half into CD into DB plus half into OC into OA. OC into OA. So what is CD? If you see CD is nothing but this. CD is nothing but time T, which is equal to OA. So hence we know what? We know CD is equal to OA is equal to T. Now clearly from the diagram, if you see OC is equal to U and OB is equal to, sorry, not OB, it's AB. AB is equal to V. So hence DB is equal to AB minus AD, which is V minus U. Okay, so let's deploy all this in this equation. So we'll get S is equal to half into CD. This CD is how much? T into DB. DB is V minus U. Okay, and then what? Plus, hey, this will not be half. Sorry, this is not half. This is rectangle. So OC into OA. So OC is how much? OC is U, and again OA is T, so it is T. So hence, if you simplify, what will you get? You will get, okay, now we can also do one thing. We can use the first equation. And first equation gives you V equals U plus AT. So you now know V minus U is equal to AT. Yeah. So you can use this in this place here. So hence what will you get? S is equal to half into T into AT plus UT. So hence answer is UT plus half. I hope this is clear to everyone. Yeah. So next is, let's move on to the next question. So the question is, a car moving with certain velocity comes to a halt. So let me just quickly copy this. Yeah. So try this problem. So car moving with a certain velocity comes to a halt if the retardation was 5 meters per second square. Find the initial velocity of the car. Try this. Yeah. So now let me solve it. So basically, uh, so what is this question? Question is, a car moves with a certain velocity, comes to a halt. If the retardation was 5 meters per second square, find the initial velocity of the car. So what is given? What is being demanded? Certain. So initial velocity is being demanded. What is this? So this is not known. So V is, so or sorry, U is not known. Okay, and comes to a halt. Halt means final velocity must be 0. Final velocity, this is final velocity. And retardation. Now the moment it is said retardation, that means acceleration will be negative. So hence I know A is minus 5 meter per second square. Okay, so U has to be found out. Okay, and yeah, so and there is no mention of time. Certain velocity comes to a halt. If the only retardation is given, find the initial velocity of the car. So how do we find out? So let's say that we we can find out the time, and okay, so we have to find out. Okay, so U is not known. Yeah, can anyone? Yeah, so you guys try. So again, what do we do in such cases? We write all of them equations. E equals to U plus AT. Then we have S is equal to UT plus half AT square, and then V square is equal to U square plus UAS. Okay, so in this case, let's apply, because there are lots of, so U is not known, S is not known, T is also not known. Okay, let us check if we can. What is known? Only A is known and V is known. A is known and V is known. So hence, okay, yeah, let me just check once. A car moving with a certain velocity comes to a halt if the retardation was 5 meters and find the initial velocity of the car. Yes, so that means it will require a combination of, so because not one single equation will not be able to give you the solution. Okay, so let's try. So, and let's try to utilize wherever V is there. So V is there in the first equation. So what can I do? I can write 0 is equal to U, which is to be found out, minus A minus 5 into T. Okay, and from the third equation, what do I get? From the third equation, you will get U square minus 2 into 5 into s. Okay, so what do I get? I get from here, I get t is equal to u upon 5. And from here, what do I get? S is equal to u square upon 10. Yeah, so I reduce t in form of, in terms of u, and then s in terms of, yeah, so u square by 10. So now what will I do? So I use two equations. Time is for the third equation to be used. So what is third equation? S is equal to u times t plus half a t square. Okay. So what is s? We just found out it is nothing but u square upon 10. So substitute is equal to u. What is u? U, let u be u, and t was u by 5. Isn't it? But no, this is not going to help you, because at the end of the day, the entire u thing will just go p square, u square, right? Yeah, this question, just a moment. So there is some time information is missing, I think. So, oh, S. So there, here, one information is missing. 62.5 it's mentioned. That was not given here. So this question is incomplete because there is 162.5 data. So that is missing. Question number 10, one data is missing, and that was S. So if S was known, then you would have solved it. Right? So hence another information which was missing here was S is equal to 62.5. So leave this equation. Now you know how to solve that. Okay, now this could be a, okay, let's try this one, 13th one. This looks a good equation, good question which will cover all the concepts. So two boys, A and B, travel along the same path. The displacement time graph for their journey is given in the following figure. Okay, let's see if you can solve. So spend 2-3 minutes on this. Let's see if you can solve this question. So I want all of you to solve this. Take some time and respond. A is 2 meter, Nihar says. Is it two boys, A and B, travel along the same path? The displacement time graph for their journey is given in the following figure. How far down the road has B traveled when A starts the journey? How far he has traveled? So B has already traveled when A starts the journey at 4th. Yeah. So if you're going to solve it through graph, it will be little difficult because so let me just, because you'll have to do some calculations also to check that the graph is scaled. Okay, let me just put it here so that all of we can also solve. Yeah, it'll be difficult to measure it from, but we'll try. Let's see. So how far down the road has B traveled when A starts the journey? So when A starts the journey, B has already, so 4 seconds, 4 minutes have elapsed. So and then basically this is displacement. So if you have to draw a vertical line, let's draw a vertical line. Yeah. So this is the vertical line. So at t equals to 4, this is somewhat near 1. So let me draw another vertical line. This is how you'll have to do. So from this point of intersection, you'll have to draw a, yeah, it looks like 1 meter. How far down the road has B traveled when A starts the journey? So B has already covered 1 meter. Next question. Without the calculation, the speed of the speed state, who is traveling faster, A or B? Who is traveling faster, A or B? Who is traveling faster? And why is A traveling faster? Why is A traveling faster? What is the reason? Why is A traveling faster, guys? Greater slope, correct. A is faster because the slope of A's displacement time graph is more. So this is A, this is B. So if you see slope of A, this inclination is more than slope of B, this angle, right? So if this angle was theta and this angle was phi, so clearly phi is greater than theta. Hence, or otherwise you can also, yeah. So Aditya saying A covers more distance in same amount of time. Yes, you can do that as well. How? So basically, you can. So let's say if you see, let's say there's a common point here, and in this much time, let's say we are taking this much time, and this is my B's curve. So B has traveled this much distance in the same time, but A. So A has traveled this much distance in the same amount of time, isn't it? So this is A's distance and this is B's distance in this time interval, delta t. So hence A is faster. So what is the speed of A? Find out. What is the speed of A? What is the speed of A? What is speed of A? How do you find out speed of A? So you have to get some known values of displacement and time. If you see, so at 4 minutes it started its journey, and let's say if you drop this perpendicular, this is 8. So in 8 from t equals to 4 to 8, it has traveled 2 meters. 2 meters. So this is my delta S, which is 2 meters from 0 to 2, and delta T is nothing but 8 minus 4 minutes. This gap is 4 minutes. Okay, so what is the speed of A? Speed of A will be, A is nothing but VA is delta S delta T, which is how much? 2 meters by 4 minute. That means 0.5 meters per minute. Meters per minute. Yeah. So you don't need to change the units. You can write this unit also. That's not a problem. Until unless specified, you can leave it here. If they are asking in SI units, then you have to change. What is the speed of B? Find the speed of B quickly. Speed of B. So speed of B is 0.25 per meter per minute. How do I find out? So again, speed of B, for speed of B, you have to find out that. Yes. So let's say if again this is 8, This is 8. So in for B, VB is equal to delta S upon delta T again. So delta S, let's say in 0 to 8 minutes, it has traversed 2 meters. Isn't it? Right? So this is 2 meters and time is 8 minutes. So hence it is 2 by 8 meter per minute. So 0.25 meters per minute. Yeah, correct. 0.25 meters per minute. Now, are the speed of A and B uniform? Are the speed of A and B uniform? Yes or no? So those who are writing only 0.25, please be careful. If you don't write the units, you will get no marks. Units are very important. Yeah, good. So they are uniform because they have constant slopes and it is a displacement time graph. Hence, what does point X on the graph represent? What does point X on the graph represent? What is the physical significance of point X? Please tell me your answer. So it is the point where A overtakes B because they are moving in the same, or you can say, yeah, A and B meet. So what happens is this is a straight line motion. So B starts first. So it's like tortoise and a hare race. So the first time, so tortoise started faster initially, and then hare overtakes it after some time. That's point X. Yeah, so it is a straight line motion. So meeting could be in two dimension also, but this is not only meeting. It is a specific case. For example, these are the two bodies moving in these two directions. They can meet here also. But this is specific case. What is happening is they are let's say traveling on a straight road, both of them. Only thing is B started first. So this is the road. So B started moving first, but B speed was slow. So after some time, let's say B was here when A started its motion. So A started its motion, and after some time again, what will happen? B is moving. So B is moving like that, and A just surpasses it. So both of them. This is the point of overtake. Okay. Next question. What is the speed of approach of A towards B? What is speed of approach of A towards B? That means if you are B, how fast A would appear to be coming towards you? So speed of approach of A towards B. Can anyone tell the answer? Yeah. So speed of approach is nothing but, what is speed of approach? So speed of approach of A towards B is velocity of A minus velocity of B. This is what is called speed of approach. So hence, if let's say if you are, this is called relative velocity also. So let's say if someone so V, the point B or the B itself, when it looks at A, it would appear that A is moving towards B with this velocity. How much is it? So A's velocity was 0.5 meters per minute minus 0.25 meters per minute. And the answer is 0.25 meters per minute. So before they meet, A would appear to be as if A is coming towards it at the rate of 0.25 meters per minute. And similarly, after they meet in this phase, now what will happen is, so you can do a analysis like this also. Let's say in 1 minute, let's say this is the point where they met. Let's say this is the point where they met, right? So what happens after 1 minute? B travels a distance of 0.25 meters, and A travels a distance of 0.5 meters. 5 meters. So how fast A is moving with respect to B is nothing but, so if someone is sitting on B, it would appear that A in the same time has moved this much distance extra. This much distance extra, and that distance is nothing but 0.25 meters. And how much time did it take to travel this extra distance? It's nothing but 1 minute. So this is the velocity of separation. So every minute there will be 0.25 meters added to the separation between B and A. After next minute, what will happen? B would have come here. So this is, let's say, after t equals to 1 minute. This is after t equals to 1 minute. After t equals to 2, t equals to 2 will be here for B. It will again travel 0.25 meters, but for A, it is another 0.5 meters. Another 0.5 meters, like that. So this is t equals to 2. So at t equals to 2, the distance between A and B is nothing but 0.5 meters. So every second 0.25 meters is added to the separation. So hence the speed of separation will be, or the question is speed of separation. Yeah, speed of separation of A from B will be 0.25 meters per minute. So I hope this gave you a good run through of the entire syllabus of motion. Let's go to laws of motion. Let's go to laws of motion. Yeah. Solve this. What is the SI unit of momentum? What was momentum? Momentum was defined as mass times the velocity of the object. So what is the SI unit of momentum? Be careful. Everyone is saying, hey, look carefully. One C, correct, kg meter per second. What is the numerical formula for force? Question number 2. Question number 2. Very good. So you know force is mass times acceleration, special case of Newton's second law. Question number 3. If the initial velocity is 0, then the force acting is. The question is little wrongly framed, but it is, if the initial velocity is 0, then the force would lead to, or yeah, it's okay. Start. So the option number B should be accelerating, not acceleration. So force acting is A, retarding, B, accelerating, C, both, D, none. So it should be accelerating. Why? Because if the initial velocity is 0 and later on it came to some velocity. That means there is a net positive change in velocity. That means positive acceleration. Okay. What is the SI unit of force? Question number 4. SI unit of force. Yes. So SI unit of force is kg meter per second square, which is also called Newton. Now here is the game. Now the subjective thing comes. State Newton's second law of motion. So quickly type in Newton's second law of motion and mention that in the comment. Quickly type in. Let's see who does it fastest. State Newton's second law of motion. Take 10-15 seconds of time. Is this answer correct? The rate of change of momentum is directly proportional to the applied force equal to external force on a body. Some bit of modification is required. Think. Rate of change of linear momentum is directly proportional to external force on the body. Jyoti. So right now when you are sitting on the table, is there no external force acting on your body? Then why are you not accelerating? Net x2. Wait, who's this? Who's busy plays? Who's this guy or girl? What's the name? I don't know. Please mention your name so that I can call it out. Varsha. Yes, Varsha. So see, I made you recite it a couple of times and it has fructified now. So you are right. You have to use the net external force, just not any external force. You have to either you write unbalanced external force or you write net external force. So the rate of change of momentum is directly proportional to the rate of change of linear momentum of a body is directly proportional to the net external force acting on the body. No, who's this? Anand? Shraddha, right? The force applied on a body is equal to product of mass and acceleration is a corollary to the second law. It's not always true. Okay, so you have to write second law is nothing but this is, you should not write anything but this. Newton's second law of motion. Newton uncle's second law. So Newton's second law of motion. Okay, what is Newton's second law of motion? It says that the rate of change of linear momentum of any body is directly proportional to net or unbalanced, whichever way you want to write, unbalanced force acting, or not another what is external force acting on the body. Okay, so this is, and then you can write in mathematically also that F is directly proportional, whichever way, delta P upon delta P. This is Newton's second law of motion. That's it. If you write even this, half the job is done. Okay, let's go to the sixth question. What is the momentum of a body of mass 200 grams moving at the velocity of 15 meters per second? Quickly do it. Nihar, check your answer, please. Again, you are doing the same mistake. You're not converting it into SI units. First thing, the moment you see any numeral value in any physics question, the first thing which should strike your mind is that number in requisite units? If it is not, then first thing you should do is convert that into SI unit, if at all it is required to. So for example, it is 200 grams. So first of all, you should convert it into kgs. It is 0.2 kg. Moving velocity of 15 meters per second. So mass times velocity is momentum. So 3 kg meter per second is the right answer. Okay, so I'm not going into question number 7, typical question. Go to question number 8. Question number 8. A force of 25 Newton acts on a mass of 500 grams resting on a frictionless surface. What is the acceleration produced? Yes, 50 meter per second square, correct. Go to question number 9. Great going, guys. You're doing good. You will be able to solve all. Chalo, let's do question number 9. Let's do question number 9 quickly. All of you are doing good. Question number 9. A force of 15 Newton acts for 5 seconds on a body of mass 5 kg, which is initially at rest. Calculate final velocity of the body. What is? Achha, tell me, what is the value of acceleration? How much is the acceleration you found out? Acceleration, is the body accelerating? First of all, yes or no? And if it is accelerating, what is the value of acceleration? Aditya, 3 will not help. Give me the units. Guys, please understand, numbers are of no value in physics. You have to give units. Ritu, it's not 3. 3 meter per second square, you'll have to mention. 15 upon 5. Yeah, check was that both of them are in SI units. So hence, clearly 15 upon 5 is the acceleration. Yeah, so what is the final velocity? So 5 second is initial velocity is 0. Acceleration is 3 meter per second square. Time is 5 seconds. So final velocity will be, final velocity is nothing but v is equal to u plus at. Use the first equation of motion. So basically, how would I solve this question? I would solve like this. So it is given, first of all, I'll draw a representative diagram. So this was my u equals to 0, and let's say and a representative, this thing. So there is F. So, and this mass is given as 5 kgs, and F is given as 25 Newton. So A is nothing but 25 upon 5, which is, I'm sorry, F was 15 Newtons. So hence it is 3 meter per second square. So acceleration was this, right? Now u is known, v is unknown, t is given as 5 seconds. So v equals u plus at. So this implies v is equal to 0 plus 3 into 5 meter per second, that is 15 meter per second. right? And then they have asked about displacement. Displacement is ut plus half at square, which is 0 into t plus half into a was 3 into t was 5 square. This is meters, in meters. So how much is it? So 2575 by 2 is 37.5 meters. Great. Now quickly differentiate between mass and weight. Quickly, one by one, you mention the points of differentiation between mass and weight. What is mass? What is weight? So Gurman, never ever start only with the characteristic. First define what is mass. Define. Start with definition. You can write all this. Mass is constant means what? Even weight is constant under certain conditions. Yeah, so mass is nothing but the amount of substance in a body, or the amount of matter contained in a body is mass. And weight is nothing but the force with which the center of the earth attracts, or the earth attracts any body. Yeah, weight is correct. Then amount of mass is scalar, perfect. Weight is vector, perfect. Mass is in kg, weight is in Newton, absolutely perfect. See, Shreya, weight is not the downward force applied by a body. It is the downward force applied, experienced by a body, not applied by a body. So our body is not applying weight. Weight is being applied by earth on us. Weight is force of the earth. Shraddha, don't write like that. Weight is the force applied by earth on any given body, on its surface, that is. Yeah, mass is constant, universally constant. So in classical physics, we say that if the body is nowhere, moving with the speed of light, if the speed is not near the speed of light, then mass stays constant for all practical purposes. It doesn't vary with time and space, right? But weight changes even on Earth, and as you go up and as you go down, weight can be zero. Yeah, weight can be zero. So weightlessness is that, let's say when you are there in space station, your weight is zero. Perfect. So all these are absolutely, so you know this difference. Now let's go to question number 11. Yeah, 11. Let's do 11. Question number 11. A scooter is moving with a velocity of 20 meters per second. Check, it is in SI unit. When brakes are applied, the mass of the scooter and the rider is 180 kg. Check, again in SI unit. The constant force applied by the brakes is 500 newtons. Check, another SI unit. So all are in SI units. First of all, you ascertain that, so you don't need to worry. Now let's go for the concept. So how long should the brakes be applied to make the scooter come to a halt? Solve it. So again, find out the deceleration in this case. All of you tell me, what is the deceleration experienced because of the braking force? What is the decelerating force? Come on guys, you can do it. Tell me. You can express in fractions. No need to convert into decimals if at all you are getting fractions. So minus 7.2 meter per second square. Okay. Is it correct? All of you agree? Ishani says minus 25 by 9. So 550, 18, 25 by 9. Correct. 25 by 9 appears to be correct. Ishani, so it's not 7.2 then. So I think Kshitiz has already solved it. Yeah. So 25 by 9 negative is the deceleration, or so acceleration is negative 25 by 9, deceleration is 25 by 9 meters per second square. How long should the brakes be applied to make the scooter come to a halt? Is nothing. V is given, U is 0. Sorry, U is given 20 meters per second. V is 0. So you have to find out the time. So most of you have got it 7.2 seconds, which looks like appears to be correct. So 20 upon 25 by 9. So 24 by 5 into 9. 4 nines are 5, 5. Yeah. 7.2 is correct. 7.2 second is correct. How far does the scooter travel before it comes to rest? So I think Kshitiz says 72 meters. Are all of you getting the same value? So you have to apply what? You can apply b square equals to u square minus 2as in this case. Yeah. So don't go for t square thingy. You can use directly v square equals to u square minus 2as. Right. So v was 0, u was 20 square minus 2 into 25 by 9. Right, into s. So this implies s equals 400 into 9 upon 58. So this is 72 meters. Perfect. So let's solve this question now. Question number 13. Stone is dropped from a height of 100 meters. How long does it take to fall the first 50 meters and the second 50 meters? Good question. Solve. 5 marker. Solve this. So stone is dropped from a height of 100 meters. How long does it take for it to fall for the first 50 meters and the second 50 meters? Okay, which do you think A and B would take more time? So in which of these two cases do you think more time will be required, in A or B? So A will take more time or B will take more time? Okay, so at least all of you are clear on this, that A will take more time. Now, so find out, in B more time will be required. Why, Nihar? In the second half, it would have been, it would already accelerate, right? It would have already accelerated to an extent. So to cross first 50 meter, it will take more time than to cross the second 50 meters. Correct. Now all of you solve it. Find out the time taken for the first 50 meters. You know S, that is first 50 is S. You know initial velocity, since it is dropped, so initial velocity is 0. T is to be found out, and A already you know, which is, so you can take acceleration due to gravity as 10 meters per second square. Root of 10 or root? I am seeing two types of answers. One is root 10, other is root 20. Should be root 10. Yeah, so the first is root 10 what? Root 10 what? Kilometers. Root 10 seconds you'll have to write. This thing is not going in your head that you have to write units. If you write like that, if you don't write units, for B it is root 50 second. Okay, let me see. Let others also. Yeah, so let me solve this question. Okay, so this is the case. Case is, this is a tower, beautiful tower it is. Okay, so let's say tower has this post where someone is standing and he drops this thing. It comes down. Let's say this is 100 meters. So half of it is 50 meters. So when it started, this direction u was 0, right? Acceleration due to gravity was plus 10 meter per second square. Okay, this is, let's say, S1 and this is S2. Now S1 is equal to 50 meters and S2 also is 50 meters. Okay, so hence when you reach here, first 50 meters is very easy. So for the first let's say the journey is A to B to C. So let us analyze the journey from A to B. Let us write everything. So initially u was 0. Acceleration during this is 10 meters per second square. And V, I don't know whatever it is, but I know S1, S is 50 meters. So I can write the second equation, S is equal to ut plus half a t square. So u was 0, so S is half a t square. So hence time taken will be nothing but 2s upon a under root. So what is, deploy the value, so 2 into 50 upon 10, which is root 10 seconds. So it takes root 10 seconds from here to here. Okay. Then I have to find out the time taken here. Let's say this time was t1. So what is t1? Root 10 seconds. Let's say this time is t2. Okay. Then what do I know? So I know the full distance. Full distance was 100. So I can again write S1 plus S2 is equal to U times T1 plus T2 total time taken plus half into A into T1 plus T2 whole square. Right? So total time from A to C. Now we are seeing what? A to C. From A to C total time was T1 plus T2. Okay. So now S1 plus S2 is clearly 100 meters. And this was 0, so hence it becomes 0. Then only thing remains is half into 10 into t1 plus t2 whole square. So this becomes 200 by 10, that is 20, is equal to t1 plus t2 whole square. That means t1 plus t2 is equal to root of 20 seconds. So total time to come down is nothing but root 20 seconds. Correct? So hence T2 will be nothing but root 20 minus T1, which was root 10. So answer is root 20 minus root 10 seconds. So this much amount of time will be taken. Yeah. Root 20 minus root 10 seconds will be required for moving from B to C, because that was what was T2. Is it clear to everyone? Any question in this? So you are mostly done. Yeah, so the second chapter also, if you are able to solve these questions, that means you are mostly there. I think we solved problems also. And let us take a few problems in gravitation so that, yeah, let me see. Yes, let's answer. Question number one. Even though stone also attracts Earth toward itself, Earth does not move. Question number one. Answer is, we have done this in the class. One answer is, question number one answer is, you don't have gravitation. Okay. So RNR doesn't have gravitation. Never mind. So it is only 2, 3 questions we'll see. Because why Shreya, why are you saying B? Because of the greater mass of Earth is so heavy that for a small force, the acceleration is too low for it to be appearing to be moving. Okay, so answer is should be A. The weight of an object is question number 2. Question number 2. Weight of an object is greater on Earth and lesser on Moon. Lesser on Earth and greater on Earth. Option B is redundant. Yes, option is A. Correct. Third, weight of an object has SI unit of. Question number 3. Question number 3, guys. Weight of an object SI unit is kg. Oh my god. No. It's A. Newton. Weight is force. Mass is SI unit will be kg. Please note. We just did the difference between mass and weight. Question number 4. Which of the statement is correct? Question number 4. Good. So I think most of you were able to solve almost every question which we discussed today. So here is my take on this. There are few do's and don'ts during the exam. So as I have already mentioned in the class also, please divide your time such that in such a way that towards the end you must spare at least 10 minutes for the revision part. Especially in numericals, please make sure that you take care of the units, because if you don't take care of units, you are most likely going to get very less marks. So let me write it down as instruction. So please follow these. First is, so do's and don'ts in exam. Do's and don'ts. First one is, do not panic, you know everything. You know everything. Because even if you panic, nothing is going to change. So do not panic, first of all. Second, spare 10 minutes at least for revisiting, for revision. And then third is put star marks on the questions which you think you should revisit. Okay, now it's not working, so I'm writing here. Okay, this is point number 3. Point number 4, be careful. In bold I'm writing careful. Be careful for or be careful for units. First thing you should do is you should convert them into SI units. So hence, please, no units, no marks. No marks. Remember this. Please make the life of examiner easier. He will make or she will make your life easier. No units, no marks. In numericals, try always to draw representative diagrams. Examiners love this. So if you express everything in picture, it is making their life easier, so they will make your life easier. So you try, and it is also useful for you because you will have a clarity in your mind. Okay, so I think you should be taking care of and especially in science subjects, wherever required, give ample amount of examples. Do not shy away from giving ample. So for example, whenever you are differentiating or you are explaining something, action, reaction, whatever, let's say if there is a if they only ask define Newton's second law, and then let's say you're seeing that there are a couple of more, the marks attached is a 2 or 3 or more. Even it is always better to give examples, but give examples only when you are very, very sure that the example is correct. Otherwise, it will backfire. Even let's say if you have right definition but wrong example, it will just create more trouble than good. So hence, if you're sure that this is a good example, then please write. Otherwise, do not enter that territory. Okay. So I think you are good. In case you are facing any other trouble, you can always send me the questions on WhatsApp. You can IM me, post it onto my individual thing, or you can do it on groups as well. No problem. And I'll try to solve all your queries as much as possible. Sir, can you share the question paper in the group? Which, acha, you're talking about these question papers? Nihar, the sample papers which we were discussing, I can share it. No problems at all. I'll share with you just after this. Okay, so I hope you guys do well. The sample paper which I'm going to share, even if you go through them and write all the answers religiously, I am sure you are going to get more than 90-95% marks. So hence, guys, you are all set. All the best for your exam. Do not panic, because panicking anyways won't help. So go there, enjoy, and share your experience in the next class or whenever we meet. So I will be logging off now. So in case if you have any trouble, you can always, and yeah, so it goes without saying, please subscribe to our channel so that there are many more such sessions we have planned. So you will get notification about those sessions and you can take advantage of them. Thanks a lot, and have a nice evening. All the best to you guys. Over and out.